All right, let's take a look at this problem. Permutations. Actually, I have done this problem before, but I want to try it with a different approach. So let's read it. Given an array nums of distinct integers, return all possible permutations. So you can return the answer in any order. So to solve this problem, we will be recursing every possible permutation. But when we are doing that, we have to make sure that we don't use the same number again. So we just want to use each one by one. So like in graph problems, we have to mark it as visited. And how do we do that? We can use dictionary to so since we have distinct integers, we can use dictionary to hold the frequencies of those and numbers and integers, and by doing that, we will be able to backtrack, like edit, like change the frequencies and mark them as visited or not. So I will be creating a result to append. So I will be returning this result, and I will be calling this DFS function, and I will be passing the current path, which will be empty, and also the index of current, and I will be using nums here, but I don't have to pass it since it is already in the scope of this function. So here I will just have this IDX, so index of the current number, and also the path. And here, so what is the base case here is if we use every possible number, like every number in the nums, then we have our index at the end of it. So if index is equal to the length of nums, then we just want to return. But in that case, it means that we have a permutation or different kind of a permutation. And so we want to append to the results. So I also want to, I just want to append the path to the result. And also, let's see, okay. Let's see. Actually, like I said, I should also send pass the frequencies. So instead of this, if I just pass these frequencies, which I will be calling a dictionary, like here, and I'm gonna pass it here. So maybe like I just pass results here, like let's make it like that, and a dictionary will be equal to. So I'll be using counter nums, and I'll be from collections import counter, so that it's easier to count every numbers. So we have the distinct integers there, and here for every number in dictionary that actually in counter we have it like this. So so for every I, the number here. So if dictionary n, if we have it so if we have it positive, then we can go in. If we have 0, then we just don't go in. So to make it 0, to mark it as visited, then we can just at the start, so to mark it as visited, we can just say dictionary n is equal to 0, or I can, so since they are distinct, yeah, I can just make it like this because it's normally 1, but I will make it to turn it to 0, and I recurse and I pass the dictionary path, and path I want to include the n like that, and I also want to pass the results, and also here I want to pass the results as well. And after this, I have to change it to 1. Change the dictionary I, the frequency, to 1, so that we just we can visit it again in the next like the recursions after this. So let's see. And there I'm passing dictionary like that. I don't have to pass the results here, but I have to pass the dictionary because it is changing. Yeah, I don't know, maybe I just have to pass it. So let's see if this works. This should be the path, length of path is equal to nums. Then I want to return it. So we have every possible permutation here, and let's check if it works. And yeah, the runtime is yeah, it works. So I will be trying permutation 2 in the next one. So I use approach from this permutations, this answer, but here I'm what it is doing is that so if we look at the, yeah, I'm gonna consider that look at that in the next videos. So for now, let's take a look at the complexity, which will be n factorial, because every time, like for every combination, it is just n factorial. And what is the space complexity? It will be okay, I'm just gonna write it here, of n factorial, and space complexity will be dictionary n, so it will be just of n, like that. Yeah, so this is my answer. And like I said, the simple idea is, the basic idea is to mark it as visited, since we have only 1 zeros, so I don't even have to do it like this, -1 and +1. I mean, like here I can also make it like 1, so it will still work. If I have 1, so it will still work. So yeah, if it is 0, we don't want to go in. So yeah, it works like that, and we have all the permutations going in, and then we append it when the length of per path is equal to the nums, because then it means that we use every number in nums, and we have a path that is equal length to the nums. So yeah,